Hi, folks. I'm Greg Elkinbard, Senior Technical Director for Mirantis. We are an OpenStack distro manufacturer and a company that installs OpenStack at lots of enterprise customers. Today, I'd like to talk to you about OpenStack logging, to tell you what we have done and what we will be doing for the OpenStack logging implementations. All right, so first, let's cover the typical logging pipeline. It consists of doing some sort of a local capture, where logs, if they're rolled into a local file, will need to be captured and processed. Some sort of a transport to get the logs to its remote destination, because we're talking about a distributed cluster. A worker, sometimes called indexer, sometimes called filter, sometimes called the transformation engine, in order to be able to massage those logs, make them uniform for storage. A scalable store that allows you to retain the logs for some time, and a way to retrieve those logs using queries and view them using some sort of a console. So in OpenStack, logging is actually fairly simple. Most of the logs are set to syslog, and Mirantis by default sets all of the OpenStack logs to go to rsyslog. The default rsyslog host is the field node for Mirantis, but it can be any external host that supports the rsyslog protocol. And we've done a number of integrations with those external hosts. We have done anything from using Flume as the transport and dumping the log data into Hadoop for later processing by Hadoop jobs, to integrating with GrayLog2, shipping the logs off to Splunk service, or integrating with Elasticsearch stack, LogStash, Elasticsearch in Kibana. And the last one is the one that we'll cover during this presentation, because it simply looks the most promising as far as logging is concerned in OpenStack. All right, so currently Mirantis will install ELK as a service delivery. In other words, we'll install it by hand, pretty much, using the Puppet recipes, of course. Eventually, we will be integrating this into Fuel, so you wouldn't have to install the LogStash and the Elasticsearch clusters by hand. The pipeline looks something like this. So it's syslog, collects all of the data on the local host, uses the rsyslog protocol to transport it to LogStash. LogStash does the filtering and massaging, real-time alert generation, and other useful things, and then stores the data in Elasticsearch cluster. We use a cluster of LogStash nodes, as you'll see on the next page, mostly for HA and an Elasticsearch cluster, both for the HA and scalability. While there's a number of consoles available for this combination, we simply currently use Kibana because it satisfies the customer needs. So let's talk about the scalability of this setup. LogStash, we've done some benchmarking in LogStash, and a completely empty pipeline can deliver roughly about 8 to 9K worth of log records if they're fairly small and like I said, no filtering has been done. But once you introduce filtering, especially if you want to start doing a little bit of transformations or real-time alerting, and your log lines are set to something reasonable, let's say 512 to 2K, then you will notice that you will be experiencing roughly about 4 to 5 K lines per second per physical host. On the Elasticsearch side, the performance question is, it depends. It depends on the message size, your application strategy, the query rate, about how hard you're hitting the engine on the back end, and even to the disk subsystem that you're using to store the data in. It's certainly possible on very, very small messages to ingest up to 8K records. But normally, with the standard two-way replication and reasonable log size, our testing indicates that only about 1K per physical host is possible. So what does it look like on an OpenStack cloud? Our rough ballpark, and by the way, this varies greatly across the cloud, so you need to do this for your own cloud, is that you probably need roughly about 200K of log lines per day per physical host, or 2.3 lines per second. So for 1,000 host compute cloud, that comes into about 3K with some spare headroom worth of log line ingest per second. And you should probably account for about 100 to 200 queries, because once the log data is in, obviously you want to mine the data for something useful, accumulation statistics, generating alerts based on trends and other information. So for 1K cloud, you need 2 LogStash nodes, mostly because you want to have an HA pair, and 3 Elasticsearch nodes, which will provide both HA and scalability capabilities. Since this is not going to be a fairly busy environment, you can host Kibana on one of these, or probably on both of the LogStash nodes. It does create 2 separate logging and monitoring pipelines. Some of the talks upstairs are actually going to cover a little bit more sophisticated approach that converges both, but that's for a deeper topic. Currently, we use the ELK simply because it's a ready-made pipeline that gives you a very, very easy access to your logs. So ELK can process numeric data, but it's probably not a very good idea to dump all of your numeric monitoring data into the Elasticsearch engine, because it's simply going to transform it into an XML document and treat them all as strings, essentially. So we use ELK for logging, and we use Zabbix for monitoring. Those systems are integrated. LogStash filters can generate real-time alerts and push them into Zabbix, as well as SMS and other systems. Queries from the Elasticsearch engines can also generate events and push them into Zabbix. And Zabbix can generate log entries from its own alerts and push them into Elasticsearch for later processing. There is obviously an alternative. Right now, ELK is Zabbix, like I mentioned before, are there. They're ready-made. They're very easy to be deployed, but they are 2 separate pipelines. There is a bit of a disadvantage with that. So what some people have started to do is they use a combination of Kafka, Storm, and Sansa to create a single transport pipeline for both logging and monitoring data, which allows them to seamlessly mine all of the data real time. Now, people like Netflix and others use this type of approach for automatic recovery of their cluster. Unfortunately, all of the automatic recovery algorithms is essentially roll your own. You go read some reference designs, and you start programming. So while this approach is great, you best have programmers on the staff. Well, you have programmers, you can travel. So that's it for the presentation. Hopefully, it has been informative.